Welcome to my factory built for the Factorio mod Astoria 2 and space exploration. We're starting at the Singularity Lab that consumes science packs in order to increase the factory's productivity. With Tier 9 speed modules, this maxed out lab consumes 185 science per minute. This tour will walk through the long chain of production built to feed this lab. Next, we're going to go to the core of this factory, the core fragment mining block. This is one of the core mining drills that pulls resources from the planet's core. Unlike conventional mines, it does not run out of resources. Nearly all resources processed by the entire factory come from one of the 113 core mining drills on 6 different planetary or lunar surfaces. Next, we'll go to the core mining fragment block. This block uses 70 pulverizers to process the core fragments into raw resources fit for production. Across all surfaces, over 100,000 core fragments are processed a minute. The resources are sent to this landing pad where they are sorted and then sent via belt or train to the rest of the factory. Next, we'll go to the processing unit factory that consumes the stone from this block. This quadrant processes stone and other resources to build electronic circuits, advanced circuits, and processing units. In addition to stone, this factory also consumes plastic, copper, and lithium. The next quadrant we'll stop at is one of 2 copper ingot factories on this surface. Copper ingots are processed into copper plates, which are used in a variety of different applications throughout the factory. Every minute, 35,000 copper plates are consumed in this factory. This factory processes copper ore with sulfuric acid to build enriched copper, which is then smelted into molten copper with the help of pyroflux and cast into copper ingots to be sent out by train. Next, we'll look at how pyroflux is created. Let's take a trip to the mall. Pyroflux is created on the moon Shennong. To get there, we're going to have to take a rocket. Shennong is an outpost that depends on the equipment built on the planet we're on in the factory block that I call the mall. From left to right, the mall includes the meteor defense installation, which knocks down meteors coming down toward the surface. It has rockets that supply all the outposts. Shennong is this one right here. It has some instrumentation that shows the status of the different parts of the factory, including all the science packs. And it also has manufactories that build almost all the buildings used throughout the entire factory. Let's take a ride to Shennong, where we can see how pyroflux is created. Welcome to Shennong. Shennong produces Vulcanite blocks, which is used for pyroflux and many other uses. Vulcanite is mined from core mining drills, and these are sent via belt into one of two Vulcanite blocks. The core fragments are processed, crushed, enriched with sulfur, and then cast with petroleum to produce Vulcanite blocks. This quadrant was copied into another area over on the northwest part of this factory where it's near raw Vulcanite. This is fed into via belt to this quadrant, and then it is sent to this area where it's sent out via rocket silos to one of 8 different places in this solar system. After the Vulcanite core fragments are processed, they produce generic core fragments. These are processed in these crushers here, sorted into this storehouse, and then sent into this area that I call the Mega Factory. The Mega Factory produces the sulfur and petroleum used to create Vulcanite blocks, and excess is used to create advanced circuits, electronic circuits, copper ingots, iron ingots, and steel ingots. These are sent back to the main factory via rocket silo. Next, we're going to take our spaceship back to Novice to see how these materials are consumed and used by the factory. This is what I call my mega landing quadrant. Each of the outposts outputs its generic resources, which are then sorted into different train stations. The Vulcanite blocks are combined with sand to create pyroflux, which is then used in different recipes, including creating copper ingots. Next, let's look at the lithium that was built for the processing circuits. In this factory, there are 2 lithium quadrants. In the lithium quadrant, stone is crushed into sand and then used to create hydrogen chloride, then combined with mineral water to produce lithium chloride, and then electrolysis is used to create lithium. Next, look at the oil block that I have. This oil block consumes crude oil core fragments to build oil. This oil is then refined to light oil, heavy oil, petroleum, gas, and even coal. These are then used to create sulfur, sulfuric acid, dynamite batteries, lithium sulfur batteries, and even used to create secure canisters. It's also used to create most of the rocket fuel used by this factory, as well as plastic that was used to create the different circuits. Next, we're going to look at how those processing units are utilized. This factory consumes the processing units to build quantum processors. This also includes using holmium, imersite, and quantum phenomenon data. The first factory that we're going to look at is how holmium is produced on the new Varpulis. We've sent back our repair ship. Spaceships can be accessed remotely, which is useful when you need to move them from one surface to another. Next, we go to Varpulis. All holmium is produced for this factory. This is my repair ship. Like every other spaceship, it's custom built, and it features force fields and laser turrets to knock down incoming meteors, a power source, and antimatter fuel. This spaceship flies all over the galaxy in order to fix outposts and broken down spaceships. Varpulis is a lot like Shennong and other outposts. It has a space elevator that allows up to 14.8 gigawatts to be produced to power all the factories. Each factory is contained in a single quadrant that processes core holmium, crushes it, creates holmium chloride with anion exchange beads, powderizes it into centrifuges with copper, smelts it with pyroflux, and casts it with sand. There are 4 of these quadrants that together produce up to 2,200 ingots a minute. Varpulis also has this mega factory and outputs via rocket silo. Now we'll go back to Novice orbit to see how those holmium ingots are used. Next, we're going to look at how holmium is utilized on Novice. To do that, we're going to go to the block where holmium cable is produced. This is the holmium ingot landing, which receives the holmium ingots and combines them with plastic bars to produce the holmium cable. Also produced the holmium solenoid. This landing also takes in the immersium plates to produce the immersium beams and gears that we'll look at. Next, we'll look at the planet Koskomino, which produces immersium crystals and imersite plates. This is Koskomino. It's a waterless planet that has the valuable resource immersium. Like other outposts, it has a space elevator with an array of solar panels to produce enough energy to power all the different quadrants. There are 2 immersium plate quadrants and 2 imersite crystal quadrants. In the crystal quadrants, Imersite core fragments are processed, crushed, mixed with sulfuric acid to produce Imercium sulfide, refined into Imersite powder with nitric acid, and crystallized with silicon to produce Imersite crystal. Next, we'll look at where quantum phenomenon data is produced in the energy science double block. This is the first of the 6 science double blocks that we'll tour. In each corner of this double wide block is one level of a science pack. In each science pack, a catalog is consumed that requires 4 different types of data. Energy 1 catalog requires conductivity, polarization, radiation, and electromagnetic field data. This catalog is then combined with holmium plates and significant data to produce the science pack. Level 2 is down here and is similar and uses force field, quantum phenomenon data, atomic and subatomic data. Level 3 is over here and follows the same pattern. And level 4 also has the same pattern. One exception is that level 4 uses star probe data. This ship travels to the nearby star Calidus, where a rocket silo launches the star probe and returns star probe data. All 4 catalogs are combined in this supercomputer to produce energy insight. This insight is used both for energy science and to produce significant data. Used data cards are recycled with supercomputers, and supercooled liquid to cool the labs is cooled using this radiation facility. Now that we've looked at how the energy block works and produces quantum phenomenon data, which was built for the quantum processor, we're going to go look at how the quantum processor is used in the AI core. This is on the surface of Novice, so we'll take our space elevator and look at the AI core. AI cores are produced from quantum processors, Imersite crystals, Vitalic reagents, bioelectric data, and advanced neural gel. Next, we'll look at how Vitalic reagents are produced on the moon Shire. Shire is rich with Vita melange and creates Vitalic products. This double-wide quadrant is where these products are created. Core fragments are crushed, processed into nuggets, bloomed in these greenhouses with fertilizer that's produced from this biomatter into this fertilizer. It is then heated into spice, refined into extract, and then finally processed into Vitalic reagents with lithium chloride and vulcanite. There are 3 of these double-wide quadrants on this moon. In addition to the moon Shire, there is a planet called Tarturus that we'll look at. Tarturus is another Vita melange planet, which has 6 of the same double quadrants used to produce the Vitalic reagent. Across all the surfaces, there are almost 400 of these Vitalic reagents produced every 5 seconds, or about 4.5 thousand a minute. These reagents are sent in by an Arco link to create Vitalic acid, Vitalic epoxy, and bioscrubbers. Next, we're going to look at the biological science, which uses these Vita melange products to create the biological science pack. Bioscience is created in the northeast part of Novice orbit. Like energy science, bioscience fits in a double-wide block, with each corner producing one level of science. Bioscience is unique in that the center is used to produce core biological components. These include nutrient gels, biocultures, and biomass. above, the neural gels are produced. These are all fed through the factory in the bus in the center, along with cooling liquids and data cards. Level 1 is produced with biocombustion, biomechanical, biochemical, and genetic data. Level 2 is produced in the same pattern, along with level 3 and level 4. The bioelectric data from Bioscience 3 and the advanced neural gel are the final two components of the AI core. Once you have the AI core built, you can use it to create the next step, which is the Naquium Processor. This is built using this gravimetrics facility from a Naquium Tesseract, Arcospheres, AI cores, and advanced neural gel. Before we get to that, we're going to have to look at the deep space science. Deep space science starts with level 1, which reads in interstellar void probe data. Now, so far, we spent almost all our time in Calidus. There's a bigger world out there, and there are many star systems and asteroid fields, one of which is Star Corps, where we get our deep science interstellar void probe data from. That data is combined with nanoengineering data, Naquium's structural data, and Naquium energy data to produce Deep Space Catalog. This is then used for the Deep Space Science Pack number. Next, we'll look at how Naquium ingots are created. Naquium ingots are created from Naquium Ore, which is shipped via a Naquium Holland spaceship like this one. Now that we've arrived at Dark Assemblage, the warehouses are filled with all the Naquitite ore. Once filled, the spaceship returns to Foenestra and then Novice to complete its delivery. Now that we've arrived back in Novice, the Naquitite ore is transported via trains down to Novice surface in order to be processed into Naquium ore. Each of the trains is powered by 4 locomotives and 5 cargo wagons. First, 20 pulverizers turn the Naquitite into crushed Naquitite. It is then processed using holmium, cation exchange beads, Vitalic acid, and refined Naquitite, Naquitite powder. Then it is crystallized with Vitalic reagents before it is cast into Naquium ingots using pyroflux and methane gas. Methane gas comes from Calidus asteroid belt, where it's loaded up and sent via rocket down to this lander. Next, we'll look at how this Naquium ingots are turned into deep space science. With Naquium ingots, level 1 of deep space science can be created. Deep Space Science 2 is created from annihilation data, which takes in particle streams and antimatter streams from quadrants like these two. There are 3 of each of these quadrants. Singularity data is created from Naquium cubes, which are created in this quadrant using nanomaterials Vulcanite, Naquium Ingots, and particle streams. Hyperlattice data is created from nanomaterials and Naquium, and gravimetrics data is created from Naquium cubes and the output of astronomic data. Astronomic data is created in the southwest. Observations from telescopes capture data from a variety of energy wavelengths to produce astronomic data. Level 1 uses infrared, visible, and ultraviolet. Level 2 uses microwave, X-ray, and gravity. Level 3 uses radio, gamma ray, and dark energy. Level 4 uses asteroid belt, black hole, 0 point, and dark energy. The visible light spectrum data is fed into this astrometrics facility to build multi-spectral astrometric analysis data, which is used throughout the astronomic research. With the astrometrics research data, the second level of Deep Space Science 2 can be created. Now, let's look at how Deep Space Science 3 is made. All 4 of the data are made using Arcosphere folding. This Arcosphere center is easily the most complex part of this factory. Let's take a closer look at how space dilation data is created. Naquium and significant data are combined using zeta and omega arcospheres. Now, the tricky part is that either 2 lambda arcospheres or 2 phi arcospheres will be generated at random. This indeterminism is repeated for all 10 of the productive arcosphere recipes. In order to maintain production, balance must be restored. There are many ways to accomplish this, and I'm quite proud of how I chose to do it. In the center, there's a warehouse that stores the arcospheres, and direct insertion is used to transmit the arcospheres into 2 of each of the 8 folding recipes. Careful inspection of this folding recipes will show that the arcospheres are segregated into 2 helical strands. In order to balance between these strands, there are 2 inversion recipes. One of the recipes converts from lambda, xi, epsilon, and phi into zeta, theta, gamma, and omega, while the other one does the inverse. Logistic bots are an essential component of a keenly balanced factory, but robot attrition makes overuse wasteful. Tier 9 speed modules, in addition to the direct insertion at the center of the warehouse, enables a responsive factory with enough throughput to feed out a maxed out science lab. But where do arcospheres come from? They are the most precious items in the factory due to being extremely expensive to collect and in limited supply. Collection is done in this Arcosphere Collection ship, which is the most high-tech ship in the fleet. It's a 100% automated ship that has multiple stages for each part of the process. Let's attach this circuit to enable the ship and walk through each of the stages. In the first stage, the ship is sent to Foenestra. Once the spatial distortion reaches 10,000, the ship is then transmitted to the asteroid field saved in the ship's memory. This happens to be the Sands of Time asteroid field. Once the ship arrives, it is anchored, and the blueprint deployer is used to create the rocket silo. Then, Arcosphere collectors are inserted into the rocket, launched, and Arcosphere collections are done. Once all 48 of the Arcosphere collectors are launched, the blueprint deployer cleans up the rocket silo, leaving the anchor, then increases the asteroid field ID that is sent for the next asteroid field, and returns back to Foenestra, then returns to Novice. This trip resulted in 7 Arcospheres that can be used for Arcolink storage or research. Next, let's look at the last of the deep space sciences. Most of the deep space sciences for level 4 require some byproduct of Arcosphere folding. An exception to this is the interstellar travel data. This can only be collected on a spaceship built to generate interstellar travel data using the Nexus. This Nexus takes in a tremendous amount of energy. 2 gigawatts of energy, which are supplied using the high temperature heat exchangers heated up by the antimatter reactors. This requires quite a large spaceship in order to generate that much energy and go fast enough to collect the interstellar travel data. That's combined with these other data packs to create the Deep Space Catalog, which finally creates the Deep Space Science Pack 4. Now that we've looked at how Bioscience 4 and Deep Space Science 4 is created, let's take a look back at our lab to see what other science packs we need. The mining productivity research requires those 2 packs, in addition to science packs developed on Novice, which are done in this factory. This is a pretty trivial science packs to create, the most complex of which is the rocket tech card, which is generated using the satellite rocket silo. The blue cards, which are made from basic components, the red cards, and the green cards. Another pack that's utilized is the science packs created in this factory, which include the Production Science Pack and the Space Science Pack. These are also fairly trivial to make, with 1 space manufactory each for them. The next science pack we'll look at is the Matter Science Pack. Matter Science is produced in the southern area of Novice orbit. For level 1, material fabricators make each of the 4 datas for Matter 1. They cannot be moduled or beaconed, so they are slow and many of them are required. Matter Science 1 uses particle streams, material testing packs, and products of energy and material research. Before we continue on to Matter Science 2, let's look at the material research block. Material research is in the southeast of Novice orbit. It primarily consumes iridium, produced on the moon Cyclops, and material testing packs. A challenge with material research is the immense amount of scrap generated. For example, in Material 2, impact shielding data is produced by smashing a locomotive against an iridium wall, generating 1,500 scrap. Another example is the pressure containment data, which processes tremendous amounts of fluid. To create a single data requires the input of 1,000 cosmic water and the output of 990 cosmic water. Careful placement of silos and pumps is required to maintain high throughput of this research. Scrap is sent via belt and train to the right side of the Matter Science block. Up to 38,000 scrap are consumed a minute in 80 recycling centers to recycle the scrap into raw resources used directly for antimatter data here or for matter in Matter Science 2. Matter utilization, stabilization, recombination, and manipulation data are used to produce Matter Science 2. These are some of the most expensive packs requiring high-level data from other research areas, AI cores, and huge amounts of raw matter. Now, as much matter is produced in the scrap processing, it's not enough to feed Matter Science 2. We'll take an elevator back to the core fragment processing area and look at the rest of the part that we kind of glossed over. As you might recall, there are 70 pulverizers in this area, and they take in different types of core fragments, both from Novice, as the generic core fragment, or different other planets, like the stone core fragments that are sent in over an Arcolink. This is what supplies the raw resources necessary to power this factory. Now, excess is sent into these matter plants, where it is turned into raw matter. Most of the raw matter comes from either copper or iron. This is then sent via train up to the Matter Science area. Now, only the right 4 of these pulverizers use the core fragments that are produced in Novice. The remaining of them are sent over these Arcolink storages. This is some of the highest tech systems in this factory, and they are produced from the limited resource Arcospheres. Each Arcolink has an ID associated with it that's dependent on the surface that it was originally built on. If you look closely, this Arcolink has a spaceship floor on it. That's because it was originally built on the moon Dawn, which has core fragments of the oil type. After being placed in the center of this spaceship, it was moved to Novice surface, and then the surrounding spaceship area was deleted, which frees a spaceship to move away and leave the Arcolink storage intact. There are quite a few Arcolinks with the ID of 10, including Pandion, Snek, Xenon, Alessandro, Wildy, in addition to Osis. These core fragments are not only used on Novice, but they're also used in Shire, where lots of mineral water and oil is consumed, and Tarturus, which also uses a lot of mineral oil and water. Next, let's look at advanced science. The core of advanced science is the combined catalog, which is built from the third level of all 4 of the space sciences. Level 1 uses remote sensing data from probes launched from a rocket silo, quantum computation data from quantum processors, and power sensing data from batteries. Level 2 uses the combined data in addition to entanglement and singularity data produced by Arcosphere folding. This is the last of the science packs that's used for mining productivity. Now you might ask yourself, what is the point of all this factory? The answer is simple. I am stuck on this god-forsaken part of this galaxy, and I need to get home. In order to get home, I am planning on using the spatial anomaly Foenestra. To use Foenestra requires a tremendous amount of power, technology, and resources. To show you what I mean, let's travel there. The Foenestra anomaly contains a wormhole artifact built by an unknown civilization. I've repaired and jerry-rigged with the resources available to me. Through expensive research and experimentation, I have discovered it was built by a spacefaring civilization that utilizes non-numerical, constellation-based navigation techniques to create wormholes across vast distances. The selection of these 8 constellations governs the precise vector the wormhole is directed to in 3-dimensional Cartesian space. Using the very expensive long-range star mapping, I have discovered the first constellation selects one of 60 facets in a pentachus dodecahedron. The remaining 7 constellations attenuate the vector with increasing precision. This graphic illustrates the triangles that make up the facets of the dodecahedron and the fractal decomposition within a singular facet. The selection of the correct constellation is based on the 60 constellations forming a bidirectional graph whose connectivity is illustrated by exploring 60 ancient ruins. For example, here is the ruin on Shennong. I have been to all 60 ruins, defeated the Biter Horde in each one, and solved the hieroglyphic puzzle to determine Foenestra Constellation Selection. In addition to selection, the gate must be anchored by 8-dimensional anchors placed in solar orbit, like this one, near the star Penthus. Each anchor requires a massive 60 gigawatts of energy and was built with the Dyson ring. The Foenestra Gate itself requires up to 90 gigawatts of energy, supplied by these antimatter reactors fed in from Novice by this Arcolink storage. I believe that I know the correct constellations, so now I'm going to select them and be on my way home. As I take this gate back to my home, please enjoy an unnarrated viewing of my factory.